So as we talk through the truss design drawing, the specifics of it down below here, we want to talk a little bit more about deflection and the bearing. So we'll get into this section. So deflection is how much the truss is going to move when it's under load. You can see that it's got a live load as well as a dead load, and then the total, all vertical in nature with the abbreviation vert. So you can see this specific one has, you know, 0.47 inch, 0.29, and 0.76. So you add those up, that's going to be the total deflection under the load there, as well as the deflection L over D, meaning, those are things that can be specified. The building designer, the engineer, whomever can say if they want it L over 360, L over 480. Those are common numbers, but a way to control how much deflection is in that truss and a way to, control stiffness. Now, you see that a lot with floor truss situations. And it is one of those things that if you're looking at deflection amongst adjacent trusses, differential deflection, that is one of those areas that if you see a huge difference there, you might have an issue and you might draw that attention to the truss technician to see what can be done to design that out of the truss. Now, getting into the bearings, we've got two bearings on this truss. They're going to have to all have, but definitely going to be looking for two on these. Now, at joint 2 and joint 8, which up here, you can see joint 2 here and then joint 8 right there. The reaction, that's how much force is going to go through the truss into those bearings. It's 10,036 pounds on the left and 11,035 on the right. Now, because those are different, this is not a symmetrical truss, and that is because of the point loads that we're going to get into when we talk about the girder loading. But know that there is a left and a right and a right and a wrong way to install this truss. You can also see that with how the plates are oriented. Some of them are different on each side, and that is important to make sure that you get those installed properly, and that's one of the indicators there. Also, some of the proprietary software companies will include a left and a right, or denote the left end on their truss placement diagrams as well as on the truss design drawing. So look for that in the field. With that, this truss was specified with 5.5 inch or 2x6 walls as bearings, but is only requiring 3.95 inches on the left and 4.34 inches on the right. Now, should something happen with that wall or something's going on funky, everything's not as was intended, that it gives you the minimum bearing requirement for this truss, which is very good to have. It's not included in all the drawings, but it is very nice to know. And there is something kind of going haywire, you can, get into that specifics once you have that problem. But by and large, you're going to be A-okay with the 2x6 bearing on this specific truss.